So working on the detailing of our question, we have calculated main bars and distribution bars. Main bars as 8 mm diameter bars at 130 mm spacing, and distribution bars 8 mm diameter bars at 270 mm spacing. Okay, so this is our scenario. There are two walls like this, and on these two walls we have supported one single one-way slab. That's why it is called one-way slab. Okay, so this inner dimension is 10 meters and this one is 3.2 meters. Okay, and this is the plan, and this section in this slab is this section. Okay, we have shown at the bottom. This is the section line. Okay, so this is the supports. The inner span is 3.2 meters and the support dimension is 230 mm, 23 centimeters. Brick wall. Okay, that's why the hatching. Okay, so we will start with, we will just mark the values like this. This dotted line, somewhat like this, will be the support, straight lines. Okay, supports, that is 230 mm. Okay, and this is 3.2 meters. Okay, and 10 meter is this dimension. Okay, or you can specify that if this can be taken as the inner dimension. There is no wall actually here. There is no wall, supporting wall. We are just drawing. Suppose there is a wall, and this is 10 meters. Okay, and this is again 230 mm. This also. So first step is complete. We have the plan and section. We don't need that actually. Okay. So first step will be laying main bars, and in one-way slab, main bars will be like in the LX direction. This is LX direction. LX, that is the spanning direction, this distance. Okay, shorter distance. Okay, so we have designed this main bars in LX direction and distribution bars for LY direction. Okay, so LX direction is in this plan, it is like this, and LY is like this in this plan. Okay, so main bars, this dimension will be, this bars with this much spacing will be provided in this length. Okay, and the peculiarity is you won't be just providing straight reinforcement. We will be cranking it. And cranking is a variation of shape used for supporting bending moment more effectively. Okay, so cranking will be done like this. So at the supports you will be having bending moment at the top. Okay, and you know that at the mid span in any simply supported beams you will be having bending moment at bottom. That's why you are providing tension members, tension reinforcement at the bottom in the beams, etc. Okay, so as we have designed it similar to beams, the same case there will be tension in here, there will be tension bending moment in here also. Okay, so at the supports there should be main reinforcement at the top portion, and at the mid span there should be main reinforcement at the bottom. Okay, and this portion like this, and this can be connected to a singular, connected as a singular reinforcement. This process of bending it is called cranking. or crank reinforcement bar, that will be called. Okay, and this dimension will be, we'll talk about it. So this is the dimension, and you won't be bending each bar like this. You will be just bending. See, if suppose one bar is starting from here, it will be like this. Okay, one bar you will be cranking it one side, and the next bar you will be cranking like this in this side. Okay, so this is our main reinforcement. Okay, so in section you will be seeing like it like this, like this. So alternate bars, one bar will be, if suppose this bar, if we are considering this bar is going like this. Okay, and the second bar from the top will be going like this. Okay, so this view can be a bit misleading if you are taking it exactly in the plan. Okay, actually in plan it will be like a straight line, but we want to include the detail of this cranking of bar. Okay, it's actually from the top, so you need to have this pictorial representation. That's why we are representing like this. Okay, actually it will be in the plan, it will be like a straight line, because the cranking is like, if this is the slab, it will be going like downwards. Okay, so please understand, this is an expression to include the details. Okay, and this distance when we should be starting this cranking is 0.1 Lx. The Lx is 3.2 meters. 10% of that length will be taken into account as Lx. Okay, you don't need to calculate and scale into or anything. You just need to mark that value. Okay, and this will be the main reinforcement, and similarly this will be 8 mm dia, 130 mm space, main bars. Okay, so that is main bars. Okay, and now we need to include distribution bars. Distribution bars will be on LY direction. Okay, so it will be, there won't be any cranking, there won't be any, because there is no supports on two ends. So you no need to give any cranking or bending up of bars. You just lay normal bars, straight bars like this. Okay, just 2 or 3 bars are enough to mark the information. So this is 8 mm dia bars at 270 mm spacing. So in here we will be marking it as small circles or dots. Okay, so these are 8 mm dia bars at 270 mm spacing, distribution bars. Okay, so that will be on the bottom side. And one more thing, you will need to provide distribution bars in here also. It can vary the numbers 2 or 3. Only 2 or 3 is enough, I think. One more thing, the spacing of this cranked bar will not be 130 actually. When you are expressing main bars, we should be providing like this. Okay, not from the crank bars. What will be the spacing of crank bars? Why would they have a change? Because only in each side only alternate bars are being bent up. Okay, so here also, although you can express it like that, it's not wrong to express as 130, but in accurate terms it should be taken up from the center portion, because center portion is where we are having 130 mm spacing. center portion is we are having 130 mm spacing. In the crank portion only alternate bars are being bent up, right? One is to the bottom, one is at the top. Okay, so top one is only having one, next one is at the bottom, right? Next one will be having cranked up, so only alternate bars are being cranked up. Okay, so the only change is nothing to calculate or anything. Only change is 8 mm dia bars at what? Double the spacing. Alternate. Only when there are 6 bars, only 3 will be cranking up. Okay, so at 260 mm center to center or spacing. Okay, so this is equal from here also. The bottom bars also only alternate ones. Okay, so in here also all alternate bars will be coming into bottom, all the other alternative bars will be coming into cranked up ports. Okay, so that's what 8 mm bars at 130 mm at the center, 8 mm bars at 260 mm at cranked portion and the bottom portion. You can only point out the crank portion itself. That's enough. Okay, so that was the point. That's the point. The main reinforcement is this one. This is distribution reinforcement. It will be the same at the top also. I mean this same. Okay, so these are LX direction distribution reinforcements. Everything in LY direction is distribution reinforcement. Everything in LX direction will be main reinforcement. The only thing to note is cranked up bars will be in spacing 260, double of main reinforcement. 130 into 2. That's the only difference. That's a small detail, minor detail. That's it.